Okay, let's take the hint. I say evaluate this integral using that substitution. So let's take a look, see what we get. All right, so first thing to do, I guess, is plug it in. And what would you get? Well, let me get back to black ink. You'd get the root 16 minus 3 times that x squared. Well, that would be 16 sine squared theta over 3. All right? And let's put the dx down now. So what's dx going to be? Dx is going to be 4 over root 3 cosine theta d theta. All right, let's write that down now. So it's going to be 4 root 3 cosine theta d theta. It looks pretty bad, but let's take a look. Certainly the 3's cancel off. I can factor 16 out, and the square root of 16 is 4, so I get 4. And then I get, let's see, 1 minus sine squared theta. I get another 4 there, so I'm going to get my eraser out, and I start seeing it's really 16 over root 3. And then I get cosine theta d theta. All right, I'm not done yet. I'm looking at this thing, and I'm starting to see something. So let's take a look at this one, 16 over root 3. Now, 1 minus sine squared theta is actually cosine squared theta. And provided I keep the theta in a region where I can take the root of it, not worrying about the sign of it. And I'm going to say the theta is between, let's think about this carefully, right? Because it's going to be cosine squared. So I'm going to be between minus pi over 2 and pi over 2. I'll be okay there, all right? So let's keep moving. And what are you going to get over here? You're going to get the cosine of theta, and that's going to be cosine squared theta, d theta. All right, let me pull that out. And I get 16 over root 3 cosine squared. It kind of reminds me of something we did in the past, if you recall, with the squares. Let me write this over here again, just to remind you, cosine 2 theta. You know what, I'm going to use x's because I'm going to confuse it. I'll use alphas. Let's see, cosine of 2 alpha is going to be the same thing as, let's see, cosine squared minus sine squared of alpha. And I'm going to write it as 2 cosine squared alpha minus 1. And I could write this as cosine 2 alpha plus 1 over 2 is the cosine squared alpha. The point of that is to reduce the degree of it from degree 2 to degree 1. Let me write that down now. We're going to get cosine of 2 theta plus 1 over 2 d theta. All right, let's keep going. And yeah, it's a long road, isn't it? And let me look at that. And I got to pull a 2 out. And I get 8 over root 3 cosine 2 theta plus 1 d theta. All right, let's keep moving. And it's going to be 8 over root 3. I think I'm ready to take the antiderivative now. That would be sine of 2 theta over 2 plus theta plus some constant of integration. I know I made a substitution, put a star there, but I guess I put stars over here too because I was making substitutions, and I need to remember that. And I'm noticing something nice about this. I'm noticing that 8 root 3, and the sine of 2 theta is really just 2 sine theta, cosine theta, and that's over 2 plus theta, plus some constant integration. Well, let's keep going. You're going to get 8 over root 3, and you're going to get what? You're going to get sine theta, cosine theta. The 2's cancel, by the way. You know what? I'm going to put a little bar there. a bracket, I mean a square bracket, plus theta plus c. All right, I'm going to return back to the land of x's, and let's go for that, all right? And then we'll check the k. So you get 8 over root 3, and then we got to do something here, don't we? So let's take a look. And I'm going to take this here, and I want to be careful about it. And what it's going to be, I'm going to say root 3 x over 4 is the same thing as sine of theta. Let me write that down for you. Root 3 x over 4 is the same thing as sine of theta. Now let's see if we can do the cosine of theta. And to do that, I'm kind of looking at some relationships over here. And let me put down my triangle here. And I can put the theta down. And let's look at it. And what are you going to get? Well, the sine would be, this would be root 3 x, this would be 4, and this would be the root of 16 minus 3x squared. All right, again, I want to remind your angle that we picked is here over here. So I don't have to worry about the sine or the cosine. It's positive between that. And let's take a look, see what we get. I don't want to do the cosine of theta. I'm doing this now, the cosine of theta. The cosine of theta is going to be the root of 16 minus 3x squared over 4. Now I can put the theta down. And what's the theta going to be? It's going to be the arc sine of, I'm looking at this by the way, root 3 over 4x, and then plus some constant. I know I'm running into my writing over there. I'll clean it up in a moment and put square over here. All right, let's take a look. And I got to multiply it out now. And I notice if I just distribute this thing across the first term, which is this here, things look pretty good. So I get, let's see, 4 goes into 2 times, and 2 goes into 4 2 times. Let me put that down. And the root 3's disappear. And what are you left off with? X root 16 minus x squared. Let me just check that again. 4 goes into 2 times, 2 goes into 4 2 times. Yeah, we're okay. Root 3's cancel, you get x. Yeah, it looks pretty good. Oops, I missed something, didn't I? I'll look at the key later. And we'll see things that we're missing just by looking at a key. Okay, let's do the next one. Plus 8 over root 3 arc sine root 3 over 4x plus c. All right, let's take a look. All right, and we're just studying, that's all we're doing. Let's see if we got the first term, this one over here. Got the x, got the 2, I got the root of that. Did I get the next thing? I see that. I see this. Yeah, I got everything. This is look good. All right, thank you.